In this problem, we're told a ball is projected upward at time t equals 0 seconds from a point on a roof 90 meters above the ground. The ball rises, then falls and strikes the ground. The initial velocity of the ball is 36.2 meters per second. If air resistance is negligible, the time when the ball strikes is closest to, and then we're given these options, right? So how do we want to solve this problem? First thing you always want to do, draw a diagram of what's going on. So we have this ball, right? It's on this roof 90 meters above the ground, right? We know it's going to be launched at some velocity, right? Which is 36.2 meters per second. Right, it's going to travel straight up and then basically back down like this. Right, it's going to strike the ground. And so what we're trying to do is find the time that this is going to take. So the way we solve these problems, or I like to, is just write down the given. So what are we given and what are we trying to find? So we're trying to find the time, right? So we can say time equals question mark because that's what we're solving for. And then what variables are we given? So we're given the initial velocity, v sub 0, right? We're told the speed at which it's launched, right? The initial velocity, which is 36.2 meters per second. So that's basically some of the variables we're given. And what we're trying to do is find right time. And basically the other variables that we're given are not explicitly told, but we basically just know them based on the problem. So we're also given the change in y. Basically, in other problems, other kinematic problems, you've probably done change in x. In this case, it's free fall, so it's going to be change in the y. So what is its change in y going to be from the beginning to the end? Okay, so it starts here, right? And if we imagine this like an axis, right? It's going to start, right? Imagine this is 0, so the bottom is 0. It's going to start 90 meters up. So if it starts at 90 and then ends at 0, what's its change in y? Well, it went from 90 to 0, right? Meaning its change in y is going to be minus 90. So the change in y is minus 90 meters, right? Because it's going to go from 90 to 0. So change in y is minus 90 meters. And then there's one other thing, which is the acceleration. So in free fall problems like this, the acceleration is just, it's not told to you because it's just explicitly known. So the acceleration in these problems is just minus 9.8 meters per second squared, right? That's the speed at which, or the acceleration due to gravity. It's just something you have to know for free fall problems because that's what acceleration is as a result of Earth's gravity. So you just assume acceleration is minus 9.8. But yeah, so basically now we have the initial velocity, we have delta y, and we have the acceleration. And if you look at the kinematic equations here, these say delta x, but they're the same for delta y, so just imagine they're delta y. But what we're trying to do is solve for t, right? And if you look at the variables we're given, notice that this one doesn't contain t, and then if you look that these don't contain, or the one we want to use is this one right here, right? Delta y equals v sub 0 times t plus 1/2 at squared. Because notice we're given v sub 0, we're given delta, right? Y, in this case, says delta x, you could just say it's y, and then we're also given a, and what we're trying to do is solve for t. So what we can do is just go ahead and plug in. So delta y equals v sub 0 times t plus 1/2 at squared. So plugging it in, delta y is minus 90 equals the initial velocity, which is 36.2 times t plus 1/2 times a, right, which is minus 9.8, and then multiply by t squared. So what you want to do is just solve this out. So minus 90 times 36.2 t plus 1/2, so this is just going to be minus 4.9, right? 1/2 times minus 9.8, and then times t squared. And so what you should notice is this is going to be in the form of quadratic, right? Because if we add this to the other side, right, this whole thing is just going to become 4.9 t squared minus 36.2 t, and then minus 90, and it's going to be equal to 0. So what you should realize is we're going to get two different answers, right? So the way you want to solve for t is you can use the quadratic equation, and I'm not going to walk you through that, but if you want to use that, you can, right? The way I recommend doing this, if your teacher allows you to do it, is just to use your graphing calculator. So all you want to do here is just go to your graphing calculator and plug in this function into, or just graph this function, right? So 4.9 and then 4.9 times t squared, right? Minus 36.2 t, and then minus 90. So 4.9 t squared minus 36.2 t minus 90, graph it, and you're going to get two different values, right? So when you get two different values, keep in mind what we're solving for t, right? So you're going to get t equals, and so there's going to be two different values, and you'll realize that one's negative, and the reason that is because basically you can imagine it on its way up. So it's really like this, and the reason one's negative is, right, because it goes up like that. But keep in mind time can't be negative, so it doesn't make sense. So our answer is only going to be the positive value when you plug it in your calculator. But yeah, so you want to plug it in your calculator and then just use the function to find where the zeros are at. Because basically what you're trying to do is find when it's 0, and that's going to be your t value. So when you plug it in for 0, you're going to get that t equals, and it's going to be 9.3517 and so on. You can just round. So I'm just going to round to 9.4. So 9.4 seconds. And if you look, E is 9.4 seconds, right? So our answer is going to be E. So basically the time that it's going to go from here to here, 9.4 seconds. But yeah, so this right here is going to be our answer. And hopefully you found this useful.